In this video I'm going to go over a demonstration of how to copy your model from the self-correcting template sheet to the blank template, and that gives you the opportunity then to expand it to longer than the 5 years, which is a bit limiting. So let's look at what we've got. We've got the basic template model here, and this has been filled in completely, so we don't have any yellow highlights left. That's all very nice, but we want to put it onto the blank template, which you'll see is already partly formatted up with the squares and some of the headings. Now, because the self-correcting templates all have protection on, and they have a lot of other tricky stuff going off in the background, we can't simply grab the whole thing and copy it. Otherwise the protection system would fail, and that would cause all sorts of problems. So what we need to do is copy the parts of the template bit by bit. And so this means simply copy and paste. Now on a Windows machine, the easiest way to do that is Control plus the C key, Control C. I've taken the general items there. I'll now just change to the blank template, and I'll go Control plus the V key, and in it goes. And I simply do that over and over again for the different components. And notice there's a bit of protection there, which is going to stop me from just simply taking that whole window. A little bit pesty, but not a great problem. And I'm simply going to go backwards and forwards, copying and pasting. And away we go. Now I've just copied a number of these windows across the top here, rather than going across through them one by one in the video to save a bit of tedium for you guys watching. And I'll just do the last couple now. I'm going to copy from the self-correcting template, and I'm going to paste into the blank template, and I'll do that for the last part here. Copy and paste. And now we have the mathematics all transferred across. Now there's a couple of changes and wrinkles. At this point, this model will be functioning correctly, although you'll notice that we've introduced a lot of yellow highlights. Why is that? Because what it's done is it imported the conditional formatting for the self-correcting mechanics into the blank template, which we don't want. So what we're going to do now is simply remove the conditional formatting from the whole sheet. And to do that, we go up to the conditional formatting tab. We ask it to go down to the clear rules section. We're going to clear rules from the entire sheet. That takes out all of the conditional formatting from the sheet, so we no longer have the nasty yellow highlights telling us that we're wrong or something. The next thing we're going to do is grow the spreadsheet over a longer period than the 5 years. After all, that's the main reason that we brought the model in here in the first place. To do that, we're going to grab these last 2 years of the model, and we're going to fill them across to the full width that we're working with. In this case, we're working with 21 years. At this point, we have all of the mathematics in, we have the conditional formatting gone, so it looks like we've finished the job. But there are a couple of tricky little places where we still need some adjustment, and that's because one way or another, while we've continued our mathematics of the DCF across those different years, there are a couple of places where we need to catch these extra years. Probably the most obvious one is for the NPV and IRR calculations. If we look here, we see that the sum of the present values, which we take for the NPV, only goes across as far as the 6th year. It actually only has to go across to the 5th year, but that doesn't matter a great deal. The big problem, though, is that now we want it to go across to the 21st year. The easy way to do that is to grab the bottom corner of it, similar to what we've done before, and simply stretch it across to the end of our new table of years. Accept that. Doesn't change the NPV because we're still working on 5 years. We're going to do a similar thing with the IRR. Here the IRR, remember the IRR calculation can only be done with a financial calculator or Excel. So this is a fairly complex piece of mathematics which is hiding behind this rather simple looking function. But we need it now to be able to cope with possible cash flows out to 21 years. Again, that's corrected. So now these two are taking the correct argument, the correct array of cells possibly. The last place that we need to adjust is probably less conspicuous, but when you think about it, it's pretty obvious, and that's when we take the net revenue for the year following the year of sale. Because at present, this figure comes in from a lookup table. We'll click on the lookup function up here to show where the arguments are coming from, and we'll notice that in the middle of it there's an array which currently only goes out to year 6. That means that the net revenue for the year following the year of sale can cope with DCF models up to 5 years long. So we simply have to stretch that across as well. We're going to take that out to 21 years. And you can take this to a larger number of years if you want, out to 40, 50, 100. A lot of commercial packages are now running to 40 years as a potential period of analysis, simply because that's considered to be the common life expectancy of a new building. However, the further out you forecast, the more rubbery your numbers get. So I'm not sure if it actually helps a great deal, but that's what's happening in the industry, so we need to be aware of it. Okay, that's the model now working out to 20 years. Let's see if it works. Well, we can look at the years owned up here, and we can change 5 up until 10. And here we see that the conditional statements are bringing in the right number of cash flows. We also see that in this last period there's capital expenditure because the depreciable inclusions have to be increased. We can take that out a little bit more, let's say to 16 years. Gives us a bit more, and we'll just play with the economic life just to demonstrate that the repeating function is working. And there you have a model which potentially you can take out a lot further than that, and you can rebuild this model for your assignment. And as I say, this is quite a powerful real life model for real life properties that you can apply, especially to single tenanted properties. But basically what's in here can be expanded, say by increasing the number of revenue rows, simply by inserting the rows and putting in similar mathematics. And also if you want more detail on your expenses, simply insert rows and put in your more detailed expenditures and so on. So it's a very powerful model, has a lot of potential for expansion, and it's mathematically equal to the best in the industry.